I'm having this question in front of me to solve, and the question is under longitude and latitude. Let me read the question and see how it goes. Find the distance between letter P and letter Q if their positional coordinates are open bracket 74 degrees east, 94 degrees north, close bracket, and open bracket 74 degrees east, 42 degrees north, close bracket, respectively. Take the radius of the earth to be 6,400 kilometers and pi is equal to 3.142. Now, before I solve this, the first thing, solution. Before I proceed to solve this question, I would like to give a definition of what latitude and longitude is. I will start with latitude. Latitude. This is a line. This is a line drawn on the globe. Drawn on the globe to show for a place. To show for a place in north or south or the equator. Full stop. Then longitude. This is a line drawn on the globe to show how far a place is west or east from the Greenwich meridian. From the Greenwich meridian. Full stop. Now, I can represent these two definitions diagrammatically. So now, I want to represent these two definitions diagrammatically. So I will have something like this as my globe. This line is called the equator. Equator. And this is my west, and this is east. So this line is a line of symmetry from north to south, and it is called axis. And lines like these, let me label this number 1, Roman figure 2. Roman figure 1 and Roman figure 2 are called lines of latitude. So if I have this line and this line, so let me label this line Roman figure 3, and I label this line Roman figure 4. So now the line Roman figure 3 and Roman figure 4 is called lines of longitude. Now, for Greenwich meridian, if I choose a standard 0 degree for the line of longitude, say this is 0 degree west and 0 degree east. So this line is called the Greenwich meridian. So now I've represented this diagrammatically. So now let me proceed to solve the question. Let me write out the point. P, open bracket, 74 degrees east, comma 94 degrees north, and Q, open bracket, 74 degrees east, comma 42 degrees north. So these are the 2 points I have. So the first thing we need to do here is to represent these 2 points on the globe. So now we need to draw another globe for this. I will assume this is my globe with an equator 0 degree north, then south. So now I'm having this 74 degrees east, 94 degrees north. So we need to identify which of these is the latitude and what longitude. So this is what latitude, why this is longitude. Latitude and longitude. So if we can identify that, then we can proceed to represent that on the globe. So now I'm having latitude 94 degrees north. So meaning that, okay, now if you look at it, I'm having for Q, the point Q to be what? The latitude for the point Q is 42 degrees north. So meaning that I will need to draw that first, the line of latitude for point Q first before the point P. So meaning that I will have the line of latitude 42 degrees north. Then the next one is line latitude 94 degrees north for point P. So I will have something like this, 94 degrees north. Now this is the axis, the line of axis. So now the longitude line, I'm having it to be 74 degrees east. So don't forget, this is west and this is east. This is east and this is for north and this is for south. So now for 74 degrees east, so meaning that the line of longitude will be like this. So I can call this 74 degrees east. Now the point of intersection, that is where I'm going to locate the 2 points. So for this, I'm having it to be point Q. Why for this, it is point P. Now from here, I can construct an angle from these 2 points like this. So this is an example of a great cycle. So now this angle theta, because for the definition of a great cycle, all the points between each other must be along the line of longitude, and you can see all the 2 points are along the line of longitude. So I can cut out this to have something like this, angle theta, then PQ. So now, having done this, I want to calculate the distance between P and Q. And the formula for that is length of an arc PQ is equal to theta over 360 times 2 pi r. Now let me label this. Theta is equal to angle between P and Q, and pi is equal to 3.142 or 22 over 7, as the case may be. So r is equal to radius of the earth, and is usually given to be 6,000 6,400 kilometer, except if the instructor give another value for the radius of the earth to be, say, 6,370, or any value to represent radius of the earth. So now the next thing here is to calculate angle theta. How do I calculate angle theta? To calculate angle theta, we need to understand two definitions. The first definition here is that latitudes that are on the same side, say north north or south south, we subtract. While the second definition, latitude that are on different side, say north south or west east, we add. Now if we look at the question, the latitude here are on the same side, so therefore we subtract in order to calculate angle theta. So meaning that theta is equal to 94 degrees minus 42 degrees, which will give us 52 degrees. So now in getting angle theta, we can substitute that in the formula of an arc PQ. So now I have length of an arc PQ is equal to 52 degrees over 360 times 2 times 3.142 times 6,400. Now I need to perform this calculation, so I will need calculator to solve this. So 52 times 2 times 3.142 times 6,400. So I have 209,1315.2 divided by 360 divided by 360. So I have 580.208889. Now kilometer, I can round off this to two decimal places, that is 5809.21 kilometer. So the distance between P and Q for the 2 points is 5809.21 kilometer. So this is my final answer. And take note of something: if you want to write your final answer, always ensure that you leave it to at least two decimal places. That is, note, always leave your answer to at least two decimal places in order to get an accurate answer. So this is my final answer to the given question. Thank you for watching.